This is Nightmare Before Best Practices. This is going to be a very different talk from all the other ones. A few years ago, I was talking with a friend of mine, and he told me that every time we go to a conference, every time we give a lecture, we talk about the success cases. We talk about how we solved things, how we fixed problems. We never talked about things that failed. We never talked about how we screwed up. And this is what I'm about to do. I'm going to tell you how my previous team managed to screw up time and time again. Because through failure, we also learn a lot. We can learn a lot from our mistakes, but no one ever said that we can't learn from other people's mistakes. If you do enjoy this presentation, do rate. If you don't, just send me an email. Seriously, because the presentation has already been approved for Berlin, so I get to do it again. So if there's something you don't enjoy about the presentation, just send me an email and say what I should change. My name is José. I work at Codacy. I happen to be a magician and a card cheater. I don't really cheat people for money. Instead, I just practice a lot, I study a lot, and then I do gambling demonstrations and some miracles for my friends. So throughout the rest of the day, if you feel like watching a miracle, just approach me and say, surprise me. To get that out of the way, I work at Codacy. We're an automated code review. That means we save you time in your code reviews, and we also help junior developers learn faster. If you want to see something about Codacy, if you want to see the 3-minute pitch, find me during the day. And today I'm going to talk to you about 4 nightmare scenarios, and in the end, I'm going to talk about some best practices that could have fixed some of those scenarios. And unlike the movie Fargo and the TV show with the same name, this story is actually true. Everything that I'm about to tell you actually happened exactly how I'm about to tell it. Nightmare number 1. The developer lost 180,000 euros. You might be thinking, how much is that in dollars? So the developer lost $200,000. And the story begins with a new website that has a shopping cart with a payment system. It integrates with a bank. And there's a successful launch, and everybody's happy for about 3 weeks. After 3 weeks, one of the developers decides to use the website himself and do a purchase. And the day after, he goes to check his bank account, and he notices there's no charge on his credit card. Peculiar, right? He goes to the back office, and he finds that there's no charges at all. But they have been selling. They have been sending the products. There's a guy here laughing. I'm betting that he's been through something like that, right? This amounts to about $34,000 per week that they've been selling. That goes about 90,000 euros so far. And something's wrong. And they call the bank and they ask what's going on. And the bank explains, well, there are 2 ways of charging customers. They might have had it, you're not using any of them. But way number 1 is you just charge the customer. It's a simple API, a simple call to an API. You pass all the data of the customer and the charge that you want to make, and you just do it. The second way is first you request the credit approval, and then you charge the client. So when you book an hotel room, for instance, you'll see that there's a pre-approved credit, and you're only charged when you go to the hotel. And what we were doing was we were authorizing, but we were never charging. And the bank added, by the way, you only have 1 week to charge the customer after you do the approval. So that means that at this point, we've lost about 60,000 euros, and if we don't act fast, we might lose 30,000 more of this week. That goes to almost $5,000 per day. So every day that goes by, we're going to lose an additional $5,000. Did I mention that this took place at a Friday afternoon? I didn't, did I? I didn't, because this actually took place at a Friday evening. And now the guy realizes we're losing $5,000 per day. So far, we've already lost more than that guy makes in a year. And if he lets the weekend go by, that's almost $15,000 more. So he has to quickly fix things. But I did tell you that this guy lost $200,000, and so far we only saw him lose $100,000. And that's where the real trouble started, with the words, you can use this code to fix it. Someone sent him a script saying, we had a similar problem in the past, we solved it with this script, you can use it as well. So the guy quickly hacked something together, it let it running during the weekend, and he figured, if I'm going to run this for the past week, maybe I can run this for the past 3 weeks, it might work. So on Monday morning, he goes to his bank account and finally, thankfully, sees something. There is a transaction with the right amount of money, but unfortunately, it's a refund. This is the best product launch ever. If they advertise this on TV, it would be selling like crazy. You buy something, you don't pay for it, you get the product, and then they send you money to your bank account. And that's how we get to $200,000. And why? Because the API on the bank side, it had all of these methods, but they all connected to the same endpoint. They were all the same one. And somewhere along the way, there was this action ID that told the bank what we wanted to do. So by using a previous script, undocumented, untested, that happened to be a script to issue refunds, to solve a different problem, the guy managed to refund everybody. And that's how we lost all of this money. Well, almost. He did lose the money, but then another guy came in, and that guy managed to blame the bank and managed to get the bank to solve the situation on their side. And I imagine that the reason they did this was because we were a really huge company with 12,000 employees. And I imagine that for the bank to lose this amount of money would be way better than to lose all the business they had with us. What happened basically was that there was no serious testing done whatsoever, no code review on the project, no code review on the script, obviously, undocumented code. Releasing on Friday is always a bad idea, although in this case it was a quick fix. He was fixing a bug, so he had to do it. And absolutely don't ever do this thing is running untested code, just because somebody says, this will solve your problem. Let's move to nightmare number 2. This was a conference, Sapo Code Bits. We're talking 1,000 attendees, free registration, but applications are moderated. So you might get in, you might not get in, and every year a lot of people didn't get in. And at the core of the event, we had, the event lasted for 3 days, 24 hours a day. It was massive, huge, insane. At the core of the event, there was a 48-hour competition. At the end of the competition, each project, each team, had 90 seconds only to present. And the users, the attendees, 1,000 of them would vote on the presentations. And this is a nightmare in 3 parts. Chapter number 1, the visitor. On the first day, and this is a very simplified version of the back office, on the first day, registration opens, people get in, and I go to see the back office, and I find myself, I'm approved, I checked in, I see my boss, he's been approved, he hasn't checked in even though he's been in the building for a few days now. And then I see this other guy who has not been approved but still managed to check in. This was a security expert who declined to provide any information on his application, so he was declined, but he still got there. He went to the registration desk, he said his name, somebody did a quick search, his name popped up. There was a line saying that this guy can't get in, but that person didn't even realize that. Hit the button check in, everything worked, and the guy walked in. And for the next 3 days, the guy went silent. No messages on Facebook, on Twitter, anything. The guy was inside the building. We had no idea what it looked like, who he was, anything. And this could result in a public relations nightmare, because almost everybody inside the building knows someone who wasn't accepted. So if they know that there's someone inside that shouldn't be there, they're going to be angry at us. And also, if that guy tells their friends about this, a lot of people could show up. This is the kind of people that I have only seen on shows like Mr. Robot. I would love to have met this guy. We never found him. Chapter number 2, the anonymous tip. So everyone has a profile, and on the back office, you can edit the profile. And we got an email from someone saying, a couple of my friends weren't accepted, and I'm really pissed at this because 2 guys they're bragging that they had this amazing idea. One of them didn't even apply to the event. The other one did. He was accepted, but he's not going to be able to be there. So instead, what they're going to do is they're going to change the picture of that guy so that the other one can go and attend. This is awful. And we had never thought about this. We get notifications for all of these fields except the photo. We managed to solve the issue. We introduced a quick fix, and we sent an email to those guys telling them they wouldn't be able to attend. They never showed up. And chapter number 3, voting. This is part of the attendees. This is a group finishing their presentation. There's 4 seconds left to vote. 80 votes in favor, 49 votes against. This consumes an immense amount of time. If we have 90 projects in 90 seconds, that's over 2 hours of project presentations. No one wants to go through that. If we had 10 seconds per project to vote, that's 2.5 hours. So every 10 seconds, it's 15 minutes more. And you want to have the same attendance in the beginning and in the end. But unfortunately, when we launched this thing, we realized that we had only tested with just a couple of people voting at the same time. And the system simply didn't work with 1,000 attendees. So we had an unauthorized entry on the first day. We had a bunch of security flaws, and we had an amazing security team. We just didn't involve them in this project. And we had part of the website down. And why? Because we weren't testing anything. We didn't account for the security issues, and there was clearly no stress testing done. And now a different kind of nightmare, a nightmare that takes place before the actual coding begins. We decided to do a travel website. So it's based on a specific content provider, and the website is going to have countries and cities, places you can visit, and a lot of information on those places, including, for instance, photos. So we set everything up. We do the specification. We do the budget for the project. It gets approved. And then, after everything is ready for coding, someone says, we'd like to use a different service for photos. And this gets approved before coding begins. There's just one tiny little detail. The original service uses location IDs, and the new one uses GPS coordinates and the location radios. You could, from a location ID, get a GPS coordinate, but that's a bit tricky because there are two schools of thoughts. There's centroids and capitals. A centroid means that you're using the GPS coordinate at the center of what you're looking at, and a capital, it's basically the capital of a country. Now, I come from Portugal, so Europe, right over here. This is what my country looks like. The capital is right here, and that is the center of the country. And if I'm using GPS coordinates, and if I want to find interesting photos of the country, I'm going to have to use a radius, and it's probably going to be a big radius because before I get to the capital, I'm going to get to Spain. That's not what I want. So I'm going to have to use a very small radius. There's just one tiny little detail. At the very core of my country, for some reason, we have this. I don't even know what that is, but that marks the center of Portugal. If we ever get involved in a war with Spain, and if we lose or gain some terrain, we're going to have to shift this thing, you know? So that's not going to work, but what about capitals? If we go to Google and search for the coordinates of Portugal, it gives us coordinates that happen to be in Lisbon, but they happen to be not what I expected, because if I'm telling you to go to Portugal, this is what I'm showing you. I'm showing you a lot of beautiful things that you can see there. I am not showing you this street that I was even not aware of. And I decided, just as a thought experiment, to go into Google Street View and see what I could find there. And this is it. And it's not as bad when you consider the opposite side of the road. You know, just come to Portugal. This is what we have for you. I also did a couple more experiments. I found out that at the very center of Spain, they sell electronic equipment. Also, the very center of Brazil is very similar to the center of Finland. The shape of the houses changed a bit. What I wasn't expecting was to find at the very center of Japan an elevator. But on closer inspection, it's not really an elevator. There's a door handle over there. That sign says staff only, and this is an emergency exit. I have no idea why a country at its very center decides to install an emergency exit for staff only. You might find it funny that I come from a country where this is the center. However, I went to look for the center of New York City. And just so you know, it's not the Empire State Building, it's not Central Park, it's not the Statue of Liberty, it's this thing. So before the project even started, we had a wrong time estimation, additional technical issues to solve, and we were definitely going to be unable to meet the deadline because it was a very, very tight deadline. Guess what? The project never even started. And this was all due to changes in the specification that were not accounted for. And now something you've probably seen before in 2 chapters. This is the last nightmare. Then we get into the best practices. Chapter 1, the laptop. A payments platform, the one from which the other script came from. And the payments platform worked really well until the developer went on vacation. And someone closed his laptop. Now, payments stopped. No one knew why. And unfortunately, the developer didn't believe in cell phones, so we couldn't reach him. If we could have reached him, we might have known that somewhere in his computer was an SSH tunnel connecting two servers. And that's why it stopped. Chapter number 2. There's a newsletter platform, and a client asks us for a new platform, and we say, yes, we'll get it ready by next week. So everything's in place. There's a campaign on TV ready to go. But then they tell us we're talking about 250,000 subscribers. And here I say that all the emails have to be sent, delivered, actually, in less than an hour. But that was the compromise. What they wanted was for 250,000 subscribers to get their newsletters at 1 o'clock precisely. And I remember asking the guys, but why at 1 o'clock? And they said, because the product is called at 1 o'clock. They wanted people to read the newsletter as they were having lunch. And unfortunately, our newsletter platform wasn't able to handle that, and we wouldn't be able to fix it in time because the platform was so huge. So instead, we decided to go with a temporary solution. Great idea, right? So the newsletter goes live, and everything works for a few days until the developer goes on vacation. And when he goes on vacation, we have no newsletter. This developer didn't have a laptop, so it couldn't be an SSH tunnel. We connected to the machine to see what was going on, and we didn't find anything relevant, but we did find a screen session, and that's never a good sign. We managed to go onto his bash history and see what kind of comments he was running on the screen session. And that took us to a database where we found this. We knew that the newsletter had 3 segments. We could see that on the previous day, there were 3 segments, 3 different registers. On the status column, there was a D. I assumed back then that the D would stand for delivered. And then we see that there are 3 segments to be delivered today, but there's something here, segment. That's odd. So I figured I'm going to delete this line. And thankfully, it worked. It worked, and then after the guy came back, we figured out what had happened. So since someone said temporary solution, the guy did something like this. There was a text area instead of a combo box where someone would type the name of the segment, and then the person would press the button, send newsletter. And why was it working? Why had it never failed until then? Well, for the same reason that the guy had stopped having lunch with us. He would sit at his laptop, waiting to see if someone would make a typo. And if someone would make a mistake, he would fix it. And then he goes on vacation and forgets to tell us about it. So the words, temporary solution. Payment stopped in one case, a newsletter wasn't sent, and basically because there was an absence of deployment methodologies and also an absence of documentation. Now, best practices, you might think that best practices exist because people are dumb. I believe that sometimes best practices exist because people are too smart. And when people are too smart, they tend to make mistakes. On the opening keynote, Martin said that sometimes people have the idea, okay, this is a great idea. No one thought about this before, but it must be a good idea nonetheless. And back where I worked, people were so brilliant. We had a huge team, 200 developers. They were so smart that we didn't have a lot of best practices. We allowed everyone to use whatever best practices they felt would be best for them. And in some cases, they were good. In some, they were not. If I could recommend just a few best practices, I would go with technical specification from the beginning, coding standards, code review definitely, and I'm talking both peer review and automated code review. And I know that I happen to work at an automated code review platform, but trust me, I'm not trying to pass any kind of subliminal image. But just in case I'm going to do it again. And also testing, a deployment methodology in place, and obviously documentation. Now, that gives me a bit more time to get into what I really wanted to talk about, and that is best practices. There are some style guides that I can strongly recommend. The opening keynote was by the Databricks, and they have this style guide online, and it's interesting because it's different from the other ones. And it's different from the other ones because they have over 800 contributors on Spark, and they figured that problems, bugs, are introduced not when the features are initially developed, but later on. So their highest priority is going to be making sure that when you change the code, you're going to understand what was there before, and you're not going to make a mistake. But there are other standards. PayPal also has a style guideline out there, and there's also the Scala style guide, and also effective Scala from Twitter. And they kind of address the same issues, not all of the same issues, but they do it differently. And it's interesting to see the differences between these standards. For instance, if we take something as simple as the maximum line length, we'll see that in some cases they go to 100 characters again, then we go down to 80 characters, and then at Twitter they say 160 characters. It's like they're saying we have a lot of money, we get to afford bigger screens, you know? But it's different, and there are reasons behind this. And by the way, if you happen to use Codacy, you can enforce most of these style guides already. But if we look at something like comments, comments are available in every language. If you went to see static analysis tools from different programming languages, would you expect to see the same patterns or different patterns? With Ruby, for instance, there's a pattern for ASCII comments. That's to enforce that comments are written in ASCII. And it kind of makes sense because you know where Ruby comes from, right? So you don't want to see kanji in the comments. You're not going to be able to figure that out, probably. There's a bunch of other patterns. Stuff like, for instance, ensuring that a comment has a leading space. But if you change to a different language, for instance, JavaScript, it's going to be a bit different. You're going to find different patterns. For instance, enforcing empty lines around comments. And that tells you a bit of where JavaScript comes from and what kind of readability they try to aim for when they design these tools. Some of them are going to be similar, but some are not. For instance, white space at the beginning of a comment is something different in JavaScript. They allow you to say whether you want to require the white space or just prohibit the white space. If you go to Java, you have a bunch of patterns. This is just page 1, that's page 2, and you get stuff like, for instance, prohibiting politically incorrect comments, which also tells you a bit about Java. This actually prevents you from writing, whoever wrote this was an idiot. Drilling down just a little bit, to-do comments. They're also different from language to language. In Java, we're looking for fix me and to-do. If we go to Scala, we're looking for fix me and to-do with little different case-sensitive options. And we can also say, I want to look for it, whether it's lowercase, uppercase, whatever. If we go to JavaScript, it's a bit more tricky because we're looking for to-do, fix me, and XXX for some reason. It's case-insensitive by default. And you can also search for those patterns in the middle of the comment, not just in the beginning. It also tells you a bit about the language. And what about regular expressions? What would you expect to find regarding Ruby, regular expressions in different languages? So if we go to Ruby, for instance, they only have 2 patterns, one in Rubocop and one in Brakeman. The one in Brakeman, which is a security tool, is to prevent unsafe regexes. That means if you're going to do a search on a regex that the user has sent you, this pattern is going to help you prevent denial of service attack. The ambiguous regex literal has something to do with Ruby itself because there is a way that the regular expression is going to be ambiguous, and when you read it, you're not going to be sure whether it's a regular expression or not. If you go to JavaScript, you have a bunch of different patterns. And these all make sense in the world of JavaScript. For instance, prohibiting an invalid regular expression. In a different language, you'd think the compiler or the interpreter is going to warn me about this when I try it. But here, you're sending your code to the user, and it's going to run there. So you may not be aware of what's happening. And something like this, prohibiting spaces in regular expressions. From where you're standing, do you know how many spaces there are between foo and bar? So the idea here is that you just type one space, and then between curly braces, you type the number of spaces that you want, because it's going to be more readable. What about Java? There's a bunch of different ones, and some of them have to do with Java itself. For instance, a file separator is something that has to do with the fact that you might be running your code on Windows or on Linux, and the file separator is going to be different. How many regular expressions patterns would you expect from a language such as Python? Any guesses? It comes down to 0. And I asked the main maintainer of PyLint why, and he said, there's no why, there's no reason. Simply, no one ever thought it would be relevant to do it. It's not something that we demand, which gets us to Perl. And I apologize in advance for the font size, but Perl has a bunch of regular patterns for regular expressions, and they all have a reasoning behind them. And the reasoning, it came up in Perl because Perl people did so much work with regular expressions, but most of these, if not all, you could take them to different languages. You could implement them in different static analysis tools. So I would say that the only reason they're not there yet is that we just simply haven't gotten around to it yet. I'm going to leave some links here as well. I'm approaching the end of the talk. I'm going to leave some links here. You don't have to note them down or anything. I'm just making sure that whenever the slides are up, you're going to get access to this. So this is some information on best practices across languages. I decided to include the links to the Scala guides as well. And I would appreciate some feedback on the session. I know you're free to tell me you still have 10 minutes more. That part I already know. That means I do have a few minutes for questions. Yes?
You talked about technical standards as best practices. Could you elaborate on that a little more? What kind of technical standards?
When you mean technical standards, you mean the coding standards, or?
As you were getting into standards, you said that some of the standards you recommend having additional coding standards, code review, testing, etc. You said technical standards, so I wondered what you meant, like what kind of.
Let me go back to that slide. I'd say this is, here we are. Yes, technical specification. From experience, to start a project without knowing what you're doing is usually a bad idea. I would recommend doing it if you're not really sure what you want to do, and if you're just elaborating on a proof of concept. That's cool. But if you're really starting a big project that has a goal, you should have a technical specification to know what you're aiming at.
Can you talk about some kind of document that just defines?
Yes, a document, not necessarily a document. What I found was that at some point we started doing this with tickets, with a ticketing system, and that allowed us, halfway through the project, to tell people on the product side, sure, you're asking for this change, but if you look at the history, that was what you asked originally, and then you asked us to change, so now you're asking us to change back again. And this is going to cost some more time. That's also going to allow the developers to defend themselves. Yes?
Codacity, the static analysis, it's a web service, and I wonder, how do you solve the problem that people would like to do that in corporations and things that your web service wouldn't be able to access? Like instead of a public GitHub or even a private GitHub repository, it's enterprise GitHub inside the firewall. How does Codacity work?
Oh, that's simple. We have an enterprise version. You can install it on your servers. It connects to GitHub Enterprise, GitLab Enterprise, all the tools that you may.
I've been doing code reviews, or I've been a proponent for like 15 years. I've contributed to a lot of static analysis tools, but the number one problem I have is with people and egos, and how do you convey always a positive message in code reviews and things that they can keep employees happy and enjoying the code review process.
Yeah.
With your experience, can you give any recommendations about some code review best practices?
Kind of. I've heard the same complaint from many people. So it's egos and how people react to code reviews, to what you tell them about code reviews. With the last team I had in my previous job, there was this guy, I found it amazing that this guy could actually separate himself from his code. And when you complain about his code, he would also insult the code. He'd be like, this is really crappy. It's like he would forget that he was the one who wrote it. And that's the way to go, you know, because you're doing your job and it's whatever was on your mind at that time. There was a guy who spoke with us just a few weeks ago, and he had a similar problem. He was working, he had a bunch of open source tools, big open source tools, and he wanted to deal with contributors, but he wanted to do it in a polite way. So he doesn't want to say, look, I want your code, I want your patch, but I don't want it the way it is because you suck. So he wants to say, sure, just fix this. And his idea was, if I introduce something like Codacy, what's going to happen is that instead of the guy seeing someone say, this code is not good enough, it's going to be an automatic message that the guy is going to see. In our case, the message is going to be, this commit is not, the quality on this commit it could be a little bit better. I think that's it. So we're trying to not confront people, you know. So we give them a list of the issues, and then we try to give them all the information that they require to solve the problems. We explain why it's an issue, how to solve it, etc., so that they will not give up. But it's an ongoing problem with ongoing solutions.
I just wanted to speak to that question because we use Codacy.
Yeah.
So what we found is that in regular code reviews where there is no automation on checking the rules, like some other developer is telling you, hey, you're doing this wrong, so this gets personal pretty easy.
Yeah.
But because the machine is telling you, basically it's like the compiler, it's telling you you are violating, you're using var, you're using this or that. And for those items which we don't agree with the style or the code style, we can go there and just turn them off selectively. So I think it works pretty well for everyone. And you still need like clear code reviews for make sure that the code does what's supposed to.
Yes.
But it comes with all the.
What we
Yeah, the ego is harmless when it's a tool.
Yeah, exactly. Well, what we found was that by using a tool such as Codacy, you're going to save time in your code review because the code review only starts after all of those smaller issues get out of the way. And then you only have to look at the actual implementation and say, this might not be the best way of solving this. Yeah. Yes?
For the documentation, could you speak a little bit more about that and what your view is on especially using a language like Scala to just write your code in a way that is really readable so that you don't need to comment it or document it?
I forget who said that clear code would not need comments. And to a certain extent, I would agree that if the code is readable, you don't have to explain the code, but you might have to explain the reasoning behind the code. So I would agree that in some cases, you're going to have to explain something so that someone 6 months ahead, maybe even you again, looking at the code again, will easily understand why it's done that way. But other than that, I always suggest investing a lot of time into documenting every single procedure, how the whole system works together, how you can use everything. And if I were to choose, every single project would begin by writing the documentation first, and then by writing tests. That's just a personal opinion. It's documentation-driven development and also test-driven development. So if there are any other questions, thank you very much, and I'll see you outside.